Hi everyone, my name is Mark and I lead research at OpenAI. Today I'm joined by Isa and Josh from our research team and also Neil from our product team. Do you guys notice anything strange?
Yeah, it looks a little different.
Well, it's because we're here in Tokyo, so hello from Tokyo everyone. The reason we're here is later on we're going to do a special event with one of our close partners, but this stream is about our next agentic offering. I want to first talk about agents as they relate to OpenAI. So OpenAI cares about agents because we believe that they're going to transform knowledge work. We think that they're going to help enterprises streamline their processes, make workers more productive, but it'll also be really, really important for consumers. So last year, we launched O1, which was the first model in our O series of reasoning models. These are models that differ from traditional models in that they think for a long time before they come up with an answer. And usually, the longer they think, the better the answer that they come up with. One of the limitations, however, of these models is that they don't have access to tools. And one of the really core missing tools is the ability to browse the internet. What this means is that a lot of the things that we use in everyday life are now not accessible to the model. So we'd like to announce a next big step. We are introducing a capability called Deep Research. What is Deep Research? Deep Research is a model that does multi-step research on the internet. And what it does is it discovers content, it synthesizes content, and it reasons about this content, adapting its plan as it uncovers more and more information. So one important feature of Deep Research, why we call it Deep Research instead of just research, is that we've removed latency constraints from the model. Typically, models return fairly quickly, but Deep Research models, they can take 5, sometimes even 30 minutes before they come back with an answer. And we think this is a good thing, not a bad thing. We think it's important for our models to start doing autonomous tasks for much longer in an unsupervised way. And this is core to our AGI roadmap as well. I think our ultimate aspiration is a model that can uncover and discover new knowledge for itself. And the first step here is a model that can go and synthesize and understand the information on the web. What you get from Deep Research is a comprehensive, fully cited research paper, essentially something that an analyst or an expert in a field might produce to you. Now, we've talked about usages for knowledge work, but there are also many usages for other things that require extensive web browsing. For instance, oftentimes you may be searching for something very, very specific, right? This also takes a lot of manual labor on the internet. You might want a specific item that you're shopping for with all these constraints that are tailored for your personal use. So it's also very good for that. I've also personally used Deep Research for putting together content for slides that I've used in a presentation. So it's very, very good across the board, across a variety of different use cases. Finally, I'm happy to announce that Deep Research is launching in Pro later today. We're going to soon roll it out to Plus and Team, and then after that to Education and Enterprise. To show you how Deep Research works, we have Neil.
Sure. Thanks, Mark. So Deep Research is in ChatGPT later today. Very excited to show you all how to use it. Deep Research is accessible from a button right here in the beginning of ChatGPT. And from here, you can immediately put in any query, and it's going to send it off to Deep Research. I'm a PM at OpenAI, and one of the things that we like to think about is what new features and products should we build? One of the things we've been tossing around is, should we build a new language translation app? And so this is something that I can ask Deep Research to go and research for me. So I'm actually going to type in this query. I want to learn a little bit more about all the different markets that I could go off and target. So I'm asking Deep Research, help me find iOS and Android adoption rates, the percent of folks who want to learn another language, and the change in mobile penetration over the past couple of years, and give me that difference between the top developed countries and developing countries. And I also really want this information in a formatted report with some tables and a clear recommendation on what the best emerging opportunities are for ChatGPT. So this is a query that would have taken me hours to put together. But with Deep Research, I can just immediately kick it off.
Is this your actual side project at OpenAI?
This is my side hustle when I'm not working on Deep Research. So what you'll first see is that Deep Research comes back with a set of clarifying questions.
This is just like a PM.
Just like a PM. This is super important because if Deep Research is going on for 30 minutes, you really want to get those requirements right. And so there's a couple of questions that it's giving to us right now. How do you want mobile penetration set up? do you want overall adoption rates or specific categories? Should the percentage of folks be on general interest or really engaged interest? These are really good questions that you'd expect an analyst to want to ask you when you're giving them a really tough prompt. And so it's really important that you can capture these up front. So I might answer something along the lines of, I want to look at this as a, give me penetration as a percentage of users and look at overall usage. And then make your best assumptions on the rest. The model is really good at taking information that's sometimes specified and a little bit more open-ended and using that to go off on a mission and get all the information that you need. So you can see right now, Deep Research has taken all of that and synthesized it and started kicking off its own research process. Deep Research is really good across a number of different knowledge work domains. And so we've seen folks being able to use it for market research, for different academic areas across physics, computer science, biology. I've been using it myself to try to PM a little bit on the side. And we're really hopeful that it'll be useful for you too at work. And so what you'll see over here is Deep Research pops open a little sidebar and it shows you all the reasoning that it's doing. So you can see right now it's identifying the top countries, it's gathering information, and it's starting its process of searching for different information. So zooming in over here, you've seen that Deep Research is searching for information, opening pages, reasoning about what it's seeing. Under the hood, what's actually happening is that the model is conducting searches, quite literally opening and browsing the pages and looking through all the different components, including images, tables, PDFs, and pulling out all of that information and using that to determine what it does next.
And it's really cool here. You can see it's using the information from one search to inform what it searches for in the next step.
Yeah, super cool. It's fun to just watch and follow it along sometimes. All right, cool. Well, while we wait for this one, I'll hand over to Josh to show us a different way of how Deep Research can work.
Thanks. Yeah, so we've talked a lot about Deep Research for knowledge work, and that's one of the use cases that we're really excited about for this. But it's not just for doing your job better. It's also useful for things that you might want to do for fun or at home. So one thing I really like to use Deep Research for is to do research on products that I might want to buy, especially for like larger purchases. Where like for me, if I'm buying something expensive, I often will like read every page about it on the internet, and I want if there's like some review somewhere that's on the internet, I want to make sure that I've taken it into consideration before I actually make the purchase. So we're here in Japan, and I've heard the skiing is pretty good this time of year. But we planned this trip a little bit last minute, so I didn't actually bring my skis. And I'm wondering if I can actually maybe just buy some skis and take a little bit of a ski vacation at the end of this. So I want to buy some skis for skiing in Japan. And one thing I like to do also is specify how Deep Research can format the output. So format this as a report with a nice table at the end. And just like in Neil's example, this is going to come back with some questions that I can choose to answer or not answer. So I'll say advanced skier, all mountain, but powder sometimes. I've heard that powder is pretty good here. Hopefully we'll get lucky
later
this week. I'm tall, so need long skis. And let's do something more fun, like maybe, I guess it'd be really cool to have like a nice color palette. So how about something with a nice color palette? And so I'll kick this off, and just like in Neil's example, Deep Research will go off and do a bunch of research on different websites on the internet, and hopefully come back with some good recommendations. So I'll hand it off to Isa to explain how this all works under the hood.
Sounds good. So Deep Research is powered by a fine-tuned version of our soon-to-be-released O3 reasoning model, and we trained it using end-to-end reinforcement learning on hard browsing and other reasoning tasks. Through that training, the model learned to plan and execute a multi-step trajectory, reacting to real-time information and backtracking when necessary. The final model is able to browse over user-uploaded files. It's also able to use a Python tool for calculations and for creating images and plots, and then it can also actually embed those plots in its final response. It's also able to embed images from websites in its final response, and when it cites its sources, it actually cites specific sentences and passages. the resulting model is able to complete tasks that would take humans many hours and that are quite complex. And it also reaches new highs on a number of both public and private evaluations. On humanity's last exam, a recently released benchmark from the Center for AI Safety and Scale AI, which tests the model's capabilities across a range of expert subjects, the Deep Research model reaches a new high of 26.6% accuracy.
That's super impressive. Humanity's last final exam too.
This test consists of around 3,000 short answer and multiple choice questions across a range of around 100 different subjects. And it's actually really cool if you see the trajectories and thinking process of the model, because it's actually very similar to how a human would solve a problem. So if I was given a really hard problem, I'd probably do some online research to try and help me figure out the answer. And we've seen examples, for example, in physics, where the model has to answer some hard calculation. It will look up an equation in an existing scientific paper and help that, and use that for answering the question. Or in a poetry example, the model had to identify a very niche poetic meter for a new poem. And so we saw it looking up examples of other existing poems and trying to help that, use that to help it reason through how to get to the answer. On another benchmark, Gaia, that measures the model's agentic capability and requires web browsing, multimodal capability, code execution, reasoning over files. The model also reaches a new high on all 3 levels of difficulty.
We've also put together some internal benchmarks that are pretty broad-based. Can you talk about those?
Yeah, for sure. So we also put together some expert-level internal evals, and we have a range of tasks that experts would do in their jobs, and we had the Deep Research model answer them, and then have the experts rate the responses. And the model was able to complete tasks that the experts said would have taken them hours, and a lot of manual investigation. So we have 2 graphs to illustrate this. So we have on the left pass rates for different estimated economic value ranges, and then on the right we have pass rate for different ranges of number of hours to complete a task. And pass rate is the rate at which the model provides a satisfactory answer to an expert level task as rated by that expert. So what's interesting from these graphs is that pass rate is more correlated with estimated economic value than it is with estimated number of hours to complete the task, which shows us that the things that the model finds difficult aren't necessarily the same things that humans find time consuming. So this graph is pass rate on these expert level tasks against the maximum number of tool calls. And what this shows us is that as the model is able to spend more time thinking and browsing, the performance increases. And this is really important because, as Mark described, we're moving towards a world where agents are going to be able to take longer and longer and complete harder and harder tasks. And so if we give them more time to think and more time to use these tools, they should be able to solve harder tasks. And then one final internal evaluation is a hallucination evaluation. And this model actually performs the best on that eval of any model we've released. However, it's still possible that it will hallucinate. So when you're making reports, make sure to check the sources yourself. And so, as we mentioned, the Deep Research model can take a really long time to respond. So we generated some examples this morning to show you the range of different things it can do. And so we can look through some of them now.
Nice. Super long.
Very, very long.
We haven't solved the scrolling to the top problem.
Okay, so this is a finance problem. So I'm an investment analyst in a Silicon Valley VC firm. I want to analyze the market for civilian supersonic air travel and prepare a thorough investment memo, and then many other specifications. And so the model clarifies, and we provided some additional requirements for the memo. And then the model kicked off the task, and as you can see, it went and researched for 7 minutes, used 12 different sources, and then came back to us with quite a comprehensive report of the field. And you can imagine if you were doing this for your job, this would be quite helpful to bootstrap your research as you're doing your initial investigation.
Yeah, hopefully this works, and next time we have to come to Japan, we'll be a little bit less jet lagged with the supersonic travel.
So here's another example. It's a biology example. So we uploaded a paper, and we want to find other papers on the same topic. This was actually a task from one of our friends at OpenAI who's very advanced in biology. So I'm not going to pretend to understand exactly what this says, but we wanted to show the range.
We're paying attention in undergrad biology.
We knew we were smart.
We want to show the range of things it can do. So it asked some clarifications, we followed up, and then this task, the model took quite a long time, and it was able to find a bunch of different papers that are on the same topic. And when we showed this to our friend, he said that it was a pretty good response. So it was a good vote of confidence for the model. And then one final example.
Over here.
Okay, so I'm sure everyone's had this moment where you can't remember the name of the restaurant that you went to in Tokyo 10 years ago, or the name of the TV show that you're looking for. And so this example might seem a bit contrived, but we wanted to show how good the model is at finding those needle in a haystack pieces of information. So the prompt is, there's a TV show that I watched a while ago. I forgot the name, but I do remember what happened in one of the episodes. Can you help me find the name? Here is what I remember in one of the episodes. 2 men play poker, one folds after another tells him to bet. And then a little bit more detail about the story. And the only additional information we were able to provide was, I think it was 5 to 10 years ago, but I'm not really sure. And the model is able to do online research and figure out, through reading a bunch of different sites and reasoning about the contents of those sites, the actual TV show episode that we're thinking of,
Wow.
which is pretty cool.
Was that the right answer? Was that the one?
That is the TV show.
Wow.
So now I'll hand back to Neil and Josh to check in on the task that you guys kicked off at the beginning.
Yeah, absolutely. Thanks, Isa. So we'll take a look at the original task over here. It actually looks like the task is still going on right now. But in the meantime, while we've kicked it off, it's already looked at 29 different sources and gone through a lot of different information. Oh, wow. OK, perfect. Good timing.
Incredible timing.
Great.
So Deep Research just put together its full analysis. It took us 11 minutes, and in that process, it looked at 29 different sites really in depth. And as you can see live on this live stream, it gave us a perfectly formatted report. Here you can see the mobile market analysis for mobile adoption and language learning. We got a nice introduction, our different adoption trends, everything put together in a really great report style where you can see mobile penetration over time and a ton of different data. And as you go down, you can see it not only has information over here, but also different table formats and ways that it's presented the data in a way that's super digestible. So one of the other things that's really cool about this model is that you're able to click in and see all the different sources that it's able to cite. Over here, you can see every citation that the model's encountered, and also different sites that it might have encountered that it didn't necessarily put into the final output, but it wants to let you know that it found along the way. Yeah. Awesome. Well,
Great. Should we check in on the skis?
let's check in on the skis.
Sounds good.
All right. Scrolling up here, what I like about this is, wow, this did a lot of research. This is the kind of thing that I would probably have to spend all afternoon just for my own sanity to make a good purchase, to read every single thing that's written about it. But this does a pretty good job of actually just doing hitting all the sites that I would hit and consolidating this all in a format that's a lot easier to digest than doing my own searches. And it also provides a table at the bottom here that just gives kind of the high-level comparison across the specific things that I mentioned that I wanted for this purchase. I find that Deep Research works really well if you're very, very specific about the type of answer that you're looking for, both in terms of what information that you want, what comparisons you want to see, and anything about the format that you want the final output in, because the model is able to take all of those things into consideration and think about them all as it does its searches and puts together its final report. So this sort of passes the sniff test for me because the top recommendation here is actually the skis that I own at home, which is kind of cool.
So love that.
I'll take a closer look at this and maybe plan a little bit of a ski trip after this.
All right. Let's go this weekend.
Yeah. So yeah, as you can imagine, there's a lot more that we can do with this technology. So I'll hand it back over to Mark to talk through where we're going with this.
Awesome. Yeah, just to recap, Deep Research is available later today on Pro, and we're soon going to bring it to desktop and mobile. But again, what we're launching today is just scratching the surface of what you can imagine us doing with Deep Research. Today, we have a Deep Research agent that browses the web. But you can imagine that same Deep Research agent connecting to custom contexts, right? Or really just kind of enterprise storages of data. Again, Deep Research is important to our AGI roadmap. We believe in agents that think longer and longer, more autonomously to solve very difficult tasks. And we believe that this, the ability to work on a task for 30 minutes really does motivate a lot more compute investment. So we're excited to see what you guys do, and please share with us. Thank you so much.